3 aircraft, altitude 60,000 feet, closure speed 1,400 knots. Lock-on warning appeared at second 6. The F-15 pilot had no support, no jammer escort, and no one believed Soviet radar could track him at that range. He was climbing when the alert hit. His onboard radar showed nothing. The RWR lit red, continuous, unblinking. He was alone. AWACS was silent. Ground command didn't respond. Protocol said this was impossible. Soviet ground radar couldn't see him at that height, couldn't track him through ECM, couldn't hold lock under evasive pattern. But the signal didn't fade. It stayed fixed. Solid tone, no pulse drop. The pilot reached for the ECM pod's active test mode. That move was forbidden during peacetime drills. NATO manuals explicitly banned unauthorized electronic pulses inside contested airspace. Engaging it would violate training doctrine, electromagnetic rules, and potentially international boundaries. He flipped the switch anyway. This happened over East Germany in 1986. During a real NATO air patrol, the Soviet radar didn't guess. It locked on. Inside the NATO Air Command Center in West Berlin. Confidence wasn't optional. It was baked into the architecture. Large-scale wall maps projected expected radar coverage zones. Thin green lines marked safe corridors above 35,000 feet. Officers walked the floor, trading jokes about Soviet hand-cranked dishes and unreliable hardware. They had numbers, charts, and an unshakable belief high altitude meant invisibility. The F-15 was the symbol of that confidence. It didn't sneak. It roared, powered by dual afterburning turbofans. It climbed faster than anything in Soviet inventory, and flew with a radar so advanced it could see enemy fighters beyond visual range. NATO doctrine framed the aircraft not just as a weapon, but as a message nothing could catch it, and nothing could touch it. The only serious threats were MiG interceptors, or SAM sites operating at full strength. Soviet radar alone was treated as background noise. Briefings told pilots they'd be picked up below 15,000 feet, possibly 25 if Soviet systems were upgraded. But 60,000 untouchable ECM doctrine even recommended shutting off countermeasures above that altitude. Doing so reduced signal footprint and conserved power. In other words, the best defense was simply being too fast and too high to matter. So when the first report came in, F-15 painted by unknown radar command didn't panic. A senior officer dismissed it as an AWACS loop. Another blamed faulty RWR calibration. One British liaison said flatly, "Their radar can't even see the moon." But the signal wasn't noise. It was stable, real, tracked. And it came from a sector NATO believed was cold. Still, no alert was issued. No doctrine was updated. The pilot's report was flagged as low priority and archived under probable simulation interference. The assumption was simple: if we can't see their radar move, it can't see us. It was wrong. For NATO pilots, flying the F-15 stealth didn't mean invisibility. It meant velocity. It meant altitude. It meant engagement profiles designed to end the fight before the enemy even knew it started. The aircraft was fast enough to outrun interceptors, agile enough to outclimb missiles, and lethal enough to fire first. Every component of the jet, from its pulse Doppler radar to its twin-engine thrust, was engineered around one assumption: if you're higher, faster, and watching first, the sky belongs to you. This assumption wasn't a fantasy. It was forged in war games, confirmed by intercepts, and written into every NATO combat manual. F-15 pilots were trained to fight from advantage, not parity. Soviet radar systems were seen as static, legacy-bound, and easily saturated. High-speed ingress routes, combined with terrain masking and selective ECM bursts, allowed NATO aircraft to operate near the Iron Curtain with near-total freedom. Any detection was considered late and irrelevant. The doctrine boiled down to timing. The F-15 was expected to detect, track, and fire before the enemy ever achieved lock. If a radar did attempt to track the aircraft, onboard warning receivers would pick it up in phases early search sweep, then tracking signal, then terminal guidance. This left windows for evasion, jamming, or simply outrunning the threat envelope. It wasn't arrogance, it was process. Simulations reinforced the belief. NATO Red Team exercises consistently showed that Soviet radar took too long to refresh, lacked resolution at high altitude, and crumbled under electronic attack. Pilots were told to treat radar warnings above 50,000 feet as false positives unless confirmed visually or by AWACS. At that altitude, they were supposed to be untouchable. To NATO strategists, speed was not just a tactic, it was doctrine. Moving fast meant reducing exposure. Climbing high meant cutting off line of sight. Every second gained was a second denied to Soviet defenses. So when the first reports surfaced of F-15s being actually tracked at 60,000 feet, it wasn't treated as a failure. It was dismissed as impossible. Not because the data was unclear, but because belief in the doctrine was stronger than belief in the signal. The air belonged to NATO. That was the truth, until Soviet radar proved it wasn't. At 0742 Zulu, an F-15C Eagle from the 32nd Tactical Fighter Squadron began a controlled vertical climb near the East German border. The mission was routine. Simulated high-speed intercept, full communications, live monitoring, no adversary aircraft in the air. Sky clear. Conditions perfect. Captain Michael Reese had executed the same maneuver dozens of times. As he passed through 55,000 feet, his radar warning receiver gave a faint blip. Then came the tone. Solid, unblinking. Band 3, ground-based. It held for 2 seconds, then 5, then 10. No fade, no pulse, just lock. It made no sense. He was at 60,000 feet, too high for Soviet GCI radar to track with precision, too fast for legacy systems to maintain resolution. He was clean, no emissions. His ECM pod was in passive mode. AWACS showed no elevated threats. NATO surveillance posts had reported no radar activity beyond baseline. The frequency was familiar, Soviet long-range tracking, but the signal strength and stability were not. Reese pulled into a shallow banking turn. Nothing changed. He initiated a descent, dropped below 58,000, still locked. The tone persisted. No shift in bearing, no Doppler modulation. It wasn't a sweep. It wasn't a pulse. It was acquisition at 52,000 feet. The signal wavered. At 50, it broke. He leveled out at 49,000. The sky was silent again. On landing, he logged the signal. Tech teams ran diagnostics. No equipment faults, no software errors. The RWR logs confirmed a solid band emission consistent with a radar operating out of East German territory, likely from Kaliningrad's deep penetration network. But there was no official record of any such radar field being online during the exercise. Soviet systems in that sector were believed to be obsolete, limited to low-angle tracking under 35,000 feet. Command flagged the report as electronic misclassification under high-altitude inversion. The explanation: the F-15's own ECM had rebounded off a cold air boundary and tricked the warning system into reading a false lock. Reese didn't believe it. He'd felt lock before, in training, in simulation, in combat. You know when a radar sweep passes over you. You feel it like wind. But this wasn't wind. It was heat. Focused. Fixed. Directed. Over dinner that night, he told another pilot what the report didn't say. They weren't searching. They were watching. The report arrived in Moscow through routine telemetry channels. It was marked as an anomaly, a successful high-altitude track by a prototype radar array stationed outside Kaliningrad. The logs showed a clean return stable, persistent, and sustained on an American F-15 flying above 60,000 feet. The Soviet radar crew confirmed the acquisition. They logged bearing, altitude, speed. They filed it under test result positive. The signal was real. High Command didn't believe it. The radar in question was part of a semi-classified project known as Nebo-M, a phased array platform designed to operate across multiple frequencies. It had been deployed silently, under camouflage, using a civilian construction cover story. Its full integration into the active air defense network wasn't scheduled for another year. Field testing was limited, calibration incomplete. No official authorization had been issued to track NATO aircraft during this stage. The generals assumed it was an internal echo, a feedback loop during pulse training. Perhaps the system had detected its own signal rebound during antenna sweep alignment. Perhaps the crew had misread the angle. Perhaps it was sunlight. They blamed training error. Someone suggested NATO was spoofing signals, throwing artificial radar reflections to lure Soviet systems into revealing operating bands. That made more sense than admitting the system had worked before it was declared operational. One colonel even asked if the Kaliningrad crew had tampered with the logs to avoid embarrassment over failed drills. No investigation followed, no commendation, no escalation order. The data was frozen and quietly archived. The idea that Soviet radar had locked onto an F-15 before Moscow said it could was too politically volatile to confront. It wasn't denial out of ignorance, it was denial out of timing. The truth had arrived before the doctrine. The first official explanation offered by Soviet analysts was elegant, technical, and wrong. They claimed the radar lock wasn't a lock at all. It was a feedback artifact caused by NATO's own electronic warfare systems. The theory emerged within 48 hours of the Kaliningrad report. According to the specialists, the F-15's ECM pod had entered an automatic calibration loop, emitting a signal pulse that was detected by the Nebo array and interpreted incorrectly as an external lock confirmation. It wasn't tracking, they said. It was a ghost. The logic was plausible. Western aircraft operating near the edge of Soviet airspace frequently activated low-level defensive systems, even during training missions. These included radar reflectors, jammer sweeps, and anti-spoofing test bursts. Under the right atmospheric conditions, a reflected emission could bounce off the upper troposphere and return to the radar in phase. The signal, if misaligned with Doppler filters, could briefly resemble an inbound target. The Nebo system, still under evaluation, might have misread it. That became the accepted theory. It explained the signal without admitting system success. It preserved the narrative that Nebo-M was not yet operational, and most importantly, it blamed the Americans. If NATO aircraft were generating misleading emissions, then the error lay with them, not with Soviet command or doctrine. No one asked why the feedback lasted nearly 20 seconds. No one explained how a false return matched the exact velocity, heading, and altitude of a real aircraft. No one addressed the fact that the lock only broke when the F-15 descended. Instead, the incident was labeled a closed-loop ECM reflection and filed under training noise. Engineers were instructed to add a software patch. A new threshold was added to the lock algorithm, just high enough to filter out similar returns in the future. It was a clean theory, tidy, comfortable, and completely false, because the radar had locked on, and the only thing jamming the truth was the need not to believe it. The second theory was worse, because it added complexity without clarity. When the jamming feedback explanation began to show cracks, another group of analysts, this time from the Soviet Aerospace Research Bureau, offered a new conclusion. The radar lock was not from direct detection, but from an echo. Specifically, They argued that the signal had bounced off a NATO AWACS orbiting further west, amplifying the return signature of the F-15 in a way that confused the Nebo system into assigning a false track. The premise was built on radar reflection theory. AWACS aircraft, with their massive rotodomes, generated wide electromagnetic signatures and sometimes caused interference with ground radar in contested zones. If the F-15 had flown behind the AWACS during a maneuver, and the Soviet radar wave had intersected that corridor at a specific angle, then according to the theory, the return signal could have been enhanced, mimicking a stable lock. The math worked. The explanation sounded official. Reports were edited to match the scenario. Diagrams were drawn. One even showed the hypothetical angle of reflection. The incident was reframed not as a success, but as an illusion created by overlapping NATO emissions. This was appealing to Soviet leadership. It exonerated the radar crew from overstepping their test parameters. It dismissed the pilot's experience as misinterpretation of indirect signal behavior. And above all, it preserved the timeline of official capability rollout. There was just one problem. No AWACS was airborne at the time. Records later confirmed that the E-3 Sentry scheduled to operate that sector had been delayed on the runway due to maintenance. There was no aircraft in the zone to produce such an echo. The theory collapsed quietly, but it had already served its purpose. It bought time. It distracted attention. It filled briefings with technical language and plausible noise. No one followed up. The failure wasn't corrected. The questions weren't revisited. Because this theory, while worse, had one advantage the truth didn't. It didn't require confronting the idea that the radar worked exactly as intended. The lock-on incident didn't just reveal new Soviet capabilities. It exposed something NATO hadn't realized it had lost awareness. In the months before the radar engagement, satellite passes over Kaliningrad showed no indications of a major radar installation. The area had once hosted a Cold War-era search complex, but according to Signals Intelligence, it had been decommissioned in 1982. Reconnaissance photos showed construction scaffolding, trucks, and a freshly poured concrete foundation, but these were logged as civilian telecom upgrades. Nothing triggered an alert. The radar wasn't built in the open. It was built inside the shell of an old facility NATO analysts had stopped watching. The Nebo array had been moved in parts, in stages, transported under civilian covers, then assembled using a modular design to mask its true configuration. It didn't look like a radar. It didn't behave like one during testing. Its emissions were limited, directed, and intermittent calibrated to remain below NATO's threshold of interest. But the bigger failure wasn't visual. It was electronic. The radar operated on a new suite of frequency-hopping bands that didn't appear in NATO's known radar library. ELINT stations in Norway and West Germany logged odd pulses coming from the region, but they didn't match anything in the database, so they were dismissed as industrial noise. The spectrum analysis software had been programmed to flag known threats, not unknown anomalies. The signals were lost in the filters. French and German technicians monitoring the Baltic EM corridor noticed short bursts of activity, but without triangulated origin and without matching signature types. The logs were buried. No report reached upper command. The British, focused on submarine tracking at the time, had deprioritized airborne radar intercepts. The Americans, confident that no Soviet radar could track a fast-maneuvering F-15 above 50,000 feet, didn't request deeper analysis. The intelligence was there. The signatures were captured. But no one looked at them twice. Even after the pilot's report, there was hesitation to revisit the raw data. The theory that Soviet radar could lock an F-15 at 60,000 feet contradicted every doctrinal assumption built since the 1970s. To admit the lock was real would mean admitting that a strategic blind spot had developed, not because the enemy hid it, but because no one believed it was possible. Inside NATO intelligence briefings, the tone remained skeptical. They reviewed the RWR logs. They studied the satellite flyovers. They traced back signal behavior. But when they found inconsistencies, they didn't ask the next question. They found excuses. It was weather. It was inversion. It was NATO's own ECM bounce. It was anything but what it actually was. A successful lock by a radar they didn't even know was active. The biggest intelligence failure wasn't that the radar was invisible. It was that NATO had stopped looking for it. The radar that locked onto the F-15 at 60,000 feet was not a single machine. It was a system distributed, layered, and modular, designed to behave like a neural net. Not a dish. At the center was the Nebo-M, the Soviet Union's most advanced ground-based radar array. But around it was a mesh of sensors, processors, and silent auxiliary stations stretching from the Baltic coast to the edge of Belarus. This was not a replacement for old systems. It was something entirely new. The core of the system was a multi-band radar suite, combining VHF, L-band, and X-band emissions. Each operated independently, but shared a common data spine. The VHF component allowed detection of stealthy or low RCS targets, albeit at low resolution. The L-band added range, while the X-band sharpened precision and offered angular accuracy. But instead of cycling between them, Nebo-M used all three simultaneously, combining their returns into a single signal synthesis model that gave it high-altitude clarity most NATO systems didn't believe was possible. It didn't just detect, it correlated. That's where the real advantage came in. While NATO relied on AWACS to integrate airborne signals, the Soviet grid embedded signal fusion at the hardware level. Each radar node sent real-time returns to a central processing unit, located off-site, sometimes miles away through encrypted fiber optic cables laid beneath civilian infrastructure. The central node ran predictive models, calculating movement vectors, acceleration curves, and radar cross-section evolution. The result was not a simple radar sweep, but a live threat profile, updated per second. If an F-15 changed altitude, speed, or heading, the system didn't just see it. It anticipated the next movement and adjusted beam focus accordingly. By the time the RWR on the F-15 blinked red, the radar had already shifted its phase array and locked ahead of the flight path. From the pilot's point of view, the signal appeared to come from nowhere. In reality, it had come from everywhere. The second breakthrough was its passive component. Scattered across the Baltic region were dozens of seemingly inactive structures, short towers, civilian communication nodes, small listening posts. These were not transmitting radar waves. They were receivers. They operated passively, listening to ambient electromagnetic noise, measuring disruptions in the spectrum caused by fast-moving bodies slicing through the air. Even if an aircraft didn't emit radar or radio signals, its presence would leave a signature: heat displacement, Doppler shifts, ionized trail data. The system could triangulate these disruptions and feed them into the Nebo-M fusion core, enhancing target recognition. This meant that even when the F-15 used emission control flying cold, the system still saw the hole it cut in the sky. The third element was predictive angle mapping. Traditional radar tracked an object's current position and velocity. Nebo-M added one more variable geometry. It calculated the radar cross-section, not just from the aircraft's surface, but from the angle of observation. A head-on F-15 was stealthier than one banking away. The system used this to predict which return angles would give the cleanest lock and preemptively reoriented beam focus to catch the aircraft in its weakest orientation. It didn't wait for the perfect shot. It moved to where it would occur. Fourth, the radar grid used low-frequency energy cycling. Most Western ECM systems were designed to jam known radar bands, especially high-frequency pulses used for targeting. Nebo-M ran alternating cycles through unpredictable frequency bands, including ultra-low frequency bursts that behaved more like seismic pulses than conventional radar waves. These weren't easy to detect, let alone jam. Even when the F-15 systems activated their defensive pods, the radar didn't need to compete. It just listened to the jamming behavior, mapped the interference shape, and used it as an additional fingerprint. The harder NATO tried to hide, the more clearly the system saw them. Fifth, the Soviet grid employed synchronized timing. Each radar and passive node in the system operated on a linked clock, accurate to within microseconds. This allowed for synthetic aperture tracking multiple returns from different locations, fused into a composite image. A maneuver that would normally fool a single radar, such as a dive or sharp bank, was tracked from 3 or more angles simultaneously. There was no blind spot, no moment of evasion. When the pilot thought he broke lock, the system had already reacquired him from another node before the turn was finished. Finally, the system didn't operate continuously. That was the most deceptive part. To avoid detection by NATO surveillance, the grid operated in low-power listen mode until it confirmed presence. Once any part of the passive net picked up a target signature heat, ionization, RCS ripple it, flipped into active sync. By the time it went live, it had already predicted the target's trajectory, approach angle, and optimal tracking vector. What felt like instant lock was actually a minute of silent prep. The radar didn't react. It ambushed. When Captain Rees's F-15 crossed into the radar envelope, the system had already seen his climb. It had mapped his speed, calculated his thrust envelope, and modeled his likely behavior. When he reached 60,000 feet, he thought he was untouchable. The system thought otherwise, and it told him so with a lock tone that didn't blink. This was no relic of Soviet engineering. It was a new doctrine built into hardware. Don't chase the aircraft, trap the sky around it. Don't scan, predict, don't reveal, confirm, and once confirmed lock, quietly and without warning. That was the system NATO never knew had gone online, until it looked straight through the F-15 and pulled the trigger on possibility. The next encounter came 2 weeks later, during a multinational NATO training patrol northeast of Bornholm Island, in international airspace, but within line of sight of Kaliningrad. 3 F-15s from the 32nd TFS, joined by 2 RAF Tornadoes and a German RF-4, were tasked with simulating a deep incursion strike. The mission was standard climb fast, maintain altitude, punch through contested air corridors, and execute a radar blackout pass near the Polish border. Every aircraft was armed only with training pods. All jamming systems were passive, no weapons, no real engagement. At 08:19 Zulu, all 3 F-15s were in formation at 59,000 feet. Weather clear, radio chatter routine. Suddenly, the lead F-15's RWR lit up. Band 3, solid tone, direct illumination. Within 6 seconds, both wingmen reported identical locks. No prior sweep, no radar search phase, just full acquisition, simultaneous. No Doppler shift, no bearing drift. That meant the radar wasn't looking for them. It was waiting for them. The lead pilot, Captain Rees again, recognized the signature. He didn't hesitate. He broke formation, nosed down, and began a defensive dive. His wingmen followed. The Tornadoes and RF-4s, still untouched, stayed level. They didn't see the threat. Only the F-15s were targeted, at 45,000 feet. Rees was still locked. At 40,000, the signal persisted. It finally broke at 37,000. But by then, the formation had shattered. The simulation had failed. The F-15s, the pride of NATO air superiority doctrine, had been forced to disengage from a non-hostile radar contact they couldn't see and couldn't defeat. Mission Control was stunned. No radar sites had gone active on NATO's threat board. AWACS hadn't picked up any pulse. No visual confirmation existed. And yet, the pilots had been painted. When the data was reviewed, post-flight, flight recorders confirmed identical timing, identical band signature, and identical descent vectors. The F-15s had all executed defensive maneuvers simultaneously, in response to a system that NATO intelligence had claimed could not yet operate at that range or altitude. For the first time, it wasn't the Soviets retreating from the sky. It was the F-15s. The Tornado crews laughed it off. The RF-4 pilots blamed hypersensitive electronics. But in the American debriefing room, there was no laughter. The RWR logs didn't lie. The signals matched. The lock had happened, and it had stayed. Captain Reese didn't file a protest. He didn't push for explanation. He simply wrote 6 words in his mission summary. They saw us before we knew. For nearly 2 decades, NATO's aerial doctrine rested on one core belief that control of the sky belonged to the side that saw first, moved first, and fired first. The F-15 was designed to embody that belief, fast enough to outrun threats, agile enough to dominate dogfights, and armed with sensors capable of sweeping the horizon long before the enemy could respond. From red flag exercises to forward deployments in Germany, the Eagle symbolized not just technological superiority, but psychological dominance. It was built to be feared. That belief died the moment Soviet radar saw the aircraft coming, before the aircraft even knew it was being watched. The doctrine of altitude as immunity collapsed first. Pilots were taught that beyond 50,000 feet, Soviet ground-based systems couldn't track fast movers with any accuracy. Exercises reflected this. Training emphasized speed and vertical maneuvering as the ultimate shield. But the radar that locked the F-15 made a mockery of that assumption. It didn't just track it anticipated. It didn't sweep it predicted. Then came the collapse of jamming as a guaranteed escape. NATO's faith in electronic warfare was deep. Generations of pilots believed that if all else failed, their countermeasures could at least break lock long enough to flee or fight. But against Nebo-M and its networked sensor grid, jamming only made them easier to follow. The more noise the aircraft emitted, the clearer its profile became to a system that had been built to learn in real time. Speed became a liability. Altitude became a weakness. Technology became a signature. Finally came the collapse of perception itself. NATO had always assumed that Soviet air defense was reactive, outdated, and largely bluff. That belief wasn't just strategic, it was cultural. It lived in the language of briefings, in the smirks during simulation, in the dismissive tone of intelligence memos. The idea that the Warsaw Pact could field a radar system more advanced than anything NATO had modeled was not simply rejected. It was unthinkable. But the signal was real. The lock was real. And for the first time in a NATO briefing room, no one could explain how they had been seen, how long they had been watched, or how deep the enemy was inside the airspace they thought was theirs. The realization was slow, and then sudden. Air superiority had never been about aircraft. It had always been about who could remain unseen longer. And now, the West had been seen, just outside Kaliningrad. The original array still stands, overgrown, weathered, fenced off with rusted steel and cold concrete blocks. The Nebo-M installation was officially decommissioned after the Soviet collapse. But it was never dismantled. The radar dish, massive, skeletal, silent faces west, just as it always did. Locals call it the Eye. Tourists are kept away. The access road is chained, yet maintained. No sign explains what it was. No plaque commemorates what it saw. But it remains. In the winter, the fog wraps around it like a memory. In the summer, its panels catch the sun. Sometimes, if you stand just close enough to the fence and the sky is quiet, you can hear a soft wind pass through the lattice like breath. The radar no longer emits, but its silence is louder than its pulse ever was. To most, it's just a Cold War relic, another piece of forgotten Soviet metal facing a world that has already moved on. But to a few pilots, especially those who flew too close, it's more than that. It's the moment they realized the sky could lie. That speed was not protection. That superiority was a matter of belief, and belief can fail. No shots were fired, no aircraft were lost, no borders were crossed. But something still broke. Not a system, not a plane, a doctrine. NATO brought the F-15 to dominate the air by force and velocity. But in 1986, a Soviet radar saw it, held it, and let it go, not because it couldn't strike, but because it didn't need to. The future wouldn't belong to the side that flew fastest. It would belong to the side that saw first. And in that moment, behind the fog and the silence, the dish still watched.